All right, welcome to today's lesson on cubic inequalities. Now, this is a fairly short, sharp lesson. It probably doesn't even need a whole double to do it in, but I might let you have the time so that we can get our heads around it, because inequalities historically is something we don't do very well on. So there's really two steps to this. There's just sketch and then look at the graph and work out which points or which parts meet the inequality criteria. All right, so we know by now that sketching involves quite a few other steps. It's not as simple as just sketching. We have to first of all find the x-intercepts, the y-intercept, the other points of interest as well. All right, so first port of call is we're going to find our factors. We might start by looking for factors of 3, which are 3 and 1, or minus 3 and minus 1. So I'll plug those in. I notice that 1 being the easiest is 1 plus 1 minus 5 plus 3, which I can straight away see is a factor because the remainder is 0. So now I could plug in 3 minus 1 and hopefully find my other factors, but I'm going to go straight to synthetic division and I'm going to divide by the factor. So I write down my coefficients here, minus 5 and 3, add down, multiply back up, add down, multiply back up, multiply back up, add down, there's my remainder. There are my 3 new coefficients, so it's x squared plus 2x minus 3. That's one set of brackets. The other set of brackets is x minus 1. So if I can factorize this left-hand set here, I find that I can get x plus 3, x minus 1, and the other factor is x minus 1 as well, which leads me to the fact that I have a repeated factor, which means it's going to be a turning point on the x-axis. So my sketch is going to look or cross through at 1 here and minus 3 here. I'm going to calculate my y-intercept now by setting x equal to 0. So looking back up the original polynomial, I can see that, oops, I'll make that a 0 so we can see 0. I'm going to have 0 plus 0 minus 0 plus 3. So it goes through up here at plus 3. And that's the only usable information I can gather out of this graph here. I've got 2 intercepts, I've got 1 y-intercept, 2 x-intercepts, 1 y-intercept. I also know it's a positive, which means it starts from the top right quadrant, comes down, hits this one here, through the y-intercept, turns somewhere in between there, and keeps going in both directions. So this is at 1, this is at minus 3. All right, so now I've sketched it. I need to know where the polynomial is less than or equal to 0. And I can see from inspection that it's less than 0 out here. It's equal to 0 here. All right, so to write my solution, I can see that x has to be less than minus 3 combined with x equals 1. All right, so it's really important at this point here that we translate this into proper notation. So I could say that the interval notation would be something like this: negative infinity to minus 3 included, because it's equal to 0, combined with a set of 1. All right, because 1 can't be an interval, it's just one value. So we could say that the inequality is satisfied at this interval combined with the set of 1. All right, so it's really important that you build on the skills you already know. So sketching, you have to find factors, then x-intercepts, most likely long division or synthetic division will be involved. Then you need to go back to the original inequality and ask yourself which values of x satisfy the inequality, paying careful attention to whether or not there is equal to or less than or greater than, and also how many times on the graph that inequality is met.